Imagine a computer so powerful it could solve problems that would take our fastest supercomputers billions of years. Problems like discovering cures for diseases in an instant, optimizing traffic in real time across entire cities, or creating encryption so secure it would be virtually unbreakable. Sounds like science fiction, right? Well, it's not. Welcome to the mind-bending world of quantum computing. In this video, we're going to break down what quantum computing actually is, how it's different from the computers we use every day, why it matters, and what the future could look like once quantum computers go mainstream. And don't worry, we're going to explain it simply, without drowning in complex equations or jargon. Let's start with the computers you already know. Classical computers, the ones in your phone, laptop, or even the server running this video, process information using bits. A bit is the most basic unit of data, and it can be in one of two states, 0 or 1. Everything you see, every photo, every video, every app is built on combinations of these zeros and ones. Powerful computers can handle billions of bits at a time, which is why they seem so fast. But even the best classical supercomputer has its limits. There are problems so complex, like simulating the behavior of molecules, optimizing vast networks, or cracking certain encryption, that they would take longer than the lifetime of the universe to solve. And that's where quantum computers come in. Instead of bits, quantum computers use qubits, short for quantum bits. Here's where things get wild. A qubit can be a 0, a 1, or both at the same time. This strange behavior is called superposition. Imagine flipping a coin. In the classical world, it's either heads or tails. But in the quantum world, it's as if the coin is spinning in midair, being both heads and tails at once, until you observe it. Now imagine you have just two qubits. They can be in 4 states at once. So 1, 10, and 11. Add just one more qubit, and now they can be in 8 states at once. With 300 qubits, a quantum computer can represent more combinations than there are atoms in the observable universe. But it doesn't stop there. There's another quantum principle that makes all this even more powerful: entanglement. When two qubits are entangled, changing the state of one instantly changes the state of the other, even if they're light years apart. Einstein famously called this spooky action at a distance. In practical terms, entanglement allows quantum computers to coordinate qubits in ways that classical computers simply can't. This gives them an edge when solving highly complex, multi-dimensional problems. So what can quantum computers actually do with all this power? Let's look at some real-world applications. Medicine and chemistry. Quantum computers could simulate molecules and chemical reactions at an atomic level, something classical computers struggle with. This could lead to the discovery of new drugs, materials, or even better batteries. Cryptography. Quantum computers might break many of today's encryption methods, especially those based on factoring large numbers. That's both exciting and terrifying, depending on whether you're the one using the quantum computer or trying to defend against it. Logistics and optimization. Quantum algorithms could optimize everything from supply chains and traffic flow to financial markets and energy grids. Imagine a world where shipping routes are recalculated in real time, minimizing costs and delays. AI and machine learning. Quantum computing could accelerate the training of AI models by exploring many possibilities simultaneously, potentially unlocking much more advanced forms of artificial intelligence. But here's the thing. Quantum computers today are still in their infancy. They're incredibly sensitive. A single stray vibration, magnetic field, or change in temperature can collapse the quantum state. This is called decoherence, and it's one of the biggest challenges researchers face. That's why quantum computers need to operate in near-perfect conditions, often at temperatures close to absolute zero, colder than outer space. Even then, today's quantum computers can only maintain their quantum state for tiny fractions of a second. Most current machines have just a few dozen stable qubits and are useful only for very specific tasks. So when do we get to the quantum future where all this becomes practical? Researchers around the world, including at Google, IBM, Intel, and startups like Rigetti and IonQ, are racing to build what's called a fault-tolerant large-scale quantum computer. Some breakthroughs have already been made. In 2019, Google claimed to achieve quantum supremacy, performing a task on a quantum computer faster than any classical computer could. While the specific task wasn't particularly useful, it proved a critical point. The potential is real, But scaling quantum computers to hundreds or thousands of reliable qubits is still a massive technical hurdle. Experts estimate that useful, general-purpose quantum computers may be available within the next decade or two. And when they arrive, they could change everything, from science and finance to cybersecurity and artificial intelligence. Now, one common myth is that quantum computers will replace classical computers. That's not true. Quantum computers are not better at everything. They're specialized tools for solving certain types of problems, ones that involve massive complexity and uncertainty. Think of them more like a new category of computing. Just as GPUs revolutionized graphics and AI, quantum machines will revolutionize problem-solving at scale. But make no mistake, the quantum revolution is coming. And like all powerful technologies, it brings both opportunity and risk. While quantum computing could help cure diseases, fight climate change, and unlock new discoveries, it could also break current encryption, disrupt financial systems, and create new cybersecurity challenges. That's why many governments, companies, and universities are investing billions into quantum research and into post-quantum cryptography, which aims to make our digital world safe from future quantum threats. So let's bring it back to you. Why should you care? Because quantum computing is not just a futuristic curiosity, it's a technological leap that could reshape our world within your lifetime. And understanding it, even at a basic level, gives you a front-row seat to one of the most important scientific revolutions of the 21st century. If you made it this far, congratulations. You now understand quantum computing better than 99% of people on the internet. And if this video helped demystify it for you, make sure to hit that like button and subscribe to TechWise for more mind-blowing insights into the future of technology. Have questions or want us to dive deeper into any part of quantum computing? Drop them in the comments below. We might feature them in a future video. Thanks for watching, and remember, in the quantum world, things aren't just weird. They're wonderfully powerful.